The purpose of this lesson is to learn about exceptions, the exception class, and generating system exceptions, learning about traditional object-oriented error handling methods, how to use the exception class's toString method and message property, how to catch multiple exceptions, how to examine the structure of the try-parse methods, how to use the finally block, how to handle exceptions when they're thrown from outside methods, to learn about the trace exception objects called through the call stack, how to create your own exception classes, and how to rethrow exceptions. An exception is simply any error condition that causes unexpected behavior in our program. Now, in our object-oriented programming languages, we actually have things that can allow us to handle this type of problem. Usually, exceptions are a member of what's called the exception class, and it does have derived classes. So what is an exception? Well, an exception is going to be something like the user typing in a number in a text field, or typing text in a numerical field, or not entering any data at all in an input field, or even trying to do something like divide by zero. So we have a large amount of class exceptions that we could encounter. We have things like system.argument exception, arithmetic exception, things like if we try to perform a conversion or if we try to divide by zero. We do have a whole bunch of different types of exceptions. However, most of them are going to come from one of the three classes. We're going to have predefined common language runtime exception classes. These come from system exception. We have application exceptions, and then also what is called the generic exception class. We can deliberately generate a system exception by forcing a program to contain an error. So if I want to try something like dividing by zero, I can force my program to crash. And I want to somehow handle that. Well, the question is, how do I handle it? Do I do it, or do I allow the program to handle the exception? We don't necessarily have to deal with the exception. What we could do is just simply state that there is an exception, but our entire intention is actually just to prevent the program from crashing. If a program crashes, we end up with this abnormal, abrupt termination of the program, and we could either lose data or we could just simply kick the user out and be an inconvenience. Object-oriented techniques actually have a lot more elegant of a solution. Alright, so in this particular case here, we have a program where it's asking the user to enter the miles that they've driven, the number of gallons of gas, and then we calculate the miles per gallon. Now, miles per gallon is just simply going to be the number of miles divided by the number of gallons, and then we figure out what the miles per gallon is. Seems easy, but if the user doesn't enter anything for the number of gallons of gas, or if they enter zero, then what we will get is an arithmetic error and possibly an exception where they divide by zero. So in this case, if they entered zero gallons of gas, we would actually get a system.divide by zero exception. And then notice it says attempted to divide by zero. We can actually take that and use it to our advantage. The system will crash, it'll throw an error, but instead of letting the entire program crash, we just simply want to grab that error message. Alright, so what we could do is we could use an if-then statement. So what we're going to do is, this is the old way, by the way, we could simply say enter the number of gallons. And then what I could do is, if the number of gallons is greater than zero, then we could divide by zero, or divide by the number of gallons. The thing is that this is actually fairly inefficient. It'll cause our code to contain a lot more evaluations than we may necessarily need. However, if it's something that we're going to do frequently, like if I frequently expect people to forget to put the mileage in, then an if-then statement will actually be a little bit faster than the other exception methods that we have available to us. But what we're going to do is we're going to try to catch that error and prevent the user from being able to go any further without crashing the program. Alright, so what we're going to use is what's called a try-catch block. Now, a try block is just simply a section of code that we're going to tell the system, try this section of code. If it works, great. If it doesn't, then we're going to catch it and we're going to try to figure out what the exception is. And we could either just simply ignore it and do nothing else and carry on like nothing happened, or we could even present a message to the user. We could reprompt them. Alright, so then we also have a thing called a finally block, and we'll get to that in just a minute. Alright, so the way that this looks is that we have a try block here. Notice it's try is the keyword. And then in curly brackets, then we actually put our code that we want to run. Then we have our catch statement, and then in curly brackets, what do we want it to do if it catches an exception? All right, so what I'm going to do is I'm going to try a small section of code. If the section of code works, great. If it doesn't work, then we're going to catch the error that we got, and then we go into this catch section of code. Think of this kind of like an if-then statement. So if this works, great, else do this thing down here. So if this works, do this code. If something up here fails, then we're going to catch it, and then we're going to do something about it. All right, so the way that this works is in our try section of code, we want to have all of our lines of code, and whichever line causes the error, that's where it actually stops. All right, so what this means is if I try this whole section of code here, then what it's going to do is it's going to try to run every one of these lines. These first four actually run, but when we get to this last one, if they entered 0, then what it would do is this line is the one that caused the exception, so it stops processing here, takes whatever the exception error message was, and throws it to the catch block. Now, a message that gets sent over, or whatever the exception was, we have to declare it. So we're going to say, okay, we have an exception. This is our data type, is an exception. We're going to call it E. And then what we could do is we could either do something with E, or we could just simply provide an output here. So it says mpg equals 0, and then it says console.writeLine you attempted to divide by 0. So if the user passes along that the number of gallons is 0, then the system is automatically going to kick it out and say, nope, miles per gallon is 0, and it's done. It's not even going to try to go back and reevaluate this. But by catching it and handling the exception, then we actually prevent the program from crashing. All right, so what would happen here in this case is they drove 300 miles, they purchased 12 gallons of gas, so they got 25 miles per gallon. In this case, they drove 300 miles, they purchased 0 gallons of gas, so they take 300 divided by 0. We get an error, so then it goes over to the catch block, and the catch block says you attempted to divide by 0, you got 0 miles per gallon. The exception class, it does contain a lot of data, and it actually has the error message directly in it. And a lot of times what we're going to want to do is we're going to want to catch that and display it to the screen to tell the user what exactly is going on. So what we're going to use is we're going to create a variable to hold the error message, and then we're going to use the .toString to be able to display the exception as a string. All right, so what I'm going to do in this case here, we have the same program. We catch the exception as E, so E is what we call it. The exception is the data type. And then this time, instead of saying something like you try to divide by 0, we're going to display whatever E is .toString. So it'll take the exception E and it converts it to a string. And then this time we get something that looks like this. So 300 miles divide by 0, system.divide by 0 exception attempted to divide by 0 at miles per gallon 3.main. So it even tells you what program caused the error message, what method, and what the exact message was. It's kind of wordy, and if we display this to the end user, they're not going to know what to do with it. So what we need to do is we need to only look at a small portion of this. All right, so if you look at this, it's system.divide by 0 exception. That is what actually threw the exception, or that's what we threw the exception to. And then the actual error is that they attempted to divide by 0. This is the message. This is what we want to display to the end user. All right, so what we're going to do is we're going to use the message property, and then we can also use the getType method to be able to figure out what the type of error message was. All right, so in this case, what we're going to do is instead of looking at E.toString, we're going to look at E.message. Now, E.message just simply means that whatever the message portion was, this attempted to divide by 0, we're going to display that out to the screen. So in this case, if they try to divide by 0, you attempted to divide by 0 is listed here, and then the rest of the program carries on. We can have as many statements in the try block as we want. The thing is that the first one that gets an error is the one that gets thrown to the exception. Typically, we only want a small section of code to be in our try block. So if I want to try to ask the user for entry for a number, then I want to try that and then catch it if they enter something wrong. If I ask them to enter a second number, then typically I'm going to have a second try block and then have another catch if they entered something wrong there. The reason for it is that I want to limit where they actually can cause errors. So if I'm asking the user for 2 numbers, and I put a try block that contains the input for both of those numbers, and they enter one of them wrong, then they have to re-enter both numbers. If I make a try block for the first number and they enter that one correctly, and then I make a separate try block for the second number and they enter that one wrong, then we only have to catch the second number and get them to re-enter that second one. So the way that it works is whatever throws the error first is the one that actually gets thrown to an exception. So in this case here, we're taking the number 13 and trying to divide by 0. And so what we're doing is we take 13, divide by 0, and this would actually cause an error. So as soon as this causes an error, it immediately exits the try block and then goes over here to the exception. Now in this case, we have multiple catch blocks here. And what we're trying to do is we're trying to catch different types of errors that the user could cause. So in this case, you'll see that we have the divide by 0 exception error, and error is what we're calling it. And then here we have index out of range exception, which we call error. So depending on which one of these we cause, if we divide it by 0 or we go out of range, it would go to the appropriate catch block, and then no matter what, it would always call it error. So in this case here, we try to divide by 0. The system would know that it's a system.divide by 0 exception error. So it immediately goes to this section of code here, and it'll say in first message block and then error dot whatever the message is. All right, so we get something like in first catch block, attempted to divide by 0. All right, but if I try to do something like this, if I change the order of the two commands, if I look at result equals array num, and num is equal to 13, I have an array here with 3 elements. So I have element 0, 1, 0, 1, and 2. Those are the only valid indexes. But here we're trying to look at index number 13. Now this is not a divide by 0 error. This is an out of range exception. So what happens is it'll throw this message or this section of code down to the catch block, and this catch block would run. So in this case, we would get a message that says the index was out of the bounds of the array. Now we can have multiple catch blocks, but we want to try to have as few as possible. All right, so what we're going to do is we're going to create multiple exceptions. And instead of simply stating that we divided by 0 and that's an error, what we want to do is we are going to have just a generic exception. So maybe I'm going to have where there's a possibility of dividing by 0. Okay, we're going to try to catch that. There's a possibility of being out of bounds. We're going to try to catch that. And then I don't want to try to evaluate all of the other possible exceptions that we could get. So we're just going to use the general exception type. So what happens here with this one is we get an error message. It just immediately treats it as an exception, and in this case we just simply state what the message is. So I could look at every possible way that they could cause an error and evaluate a catch block for each one, or I could just simply have a generic exception. So typically what you'll see would be maybe 2 or 3 exception catch blocks. So we'd have one that tries to catch the out of bounds, one that tries to catch dividing by 0, and then another one that is just the generic, hey, you cause an exception, here's your error. All right, so it is considered to be poor coding style to have more than 3 or 4 exceptions in our code. Honestly, we shouldn't have any more than 2 or 3. And the reason for it is only one of these is actually going to run whenever the program runs. So if I create an exception for the divide by 0, or I create an exception for out of bounds, only one of the 2 of those is going to run. So what would happen is I end up with these what are called unreachable blocks, which are just simply blocks of code that the system will never actually make it to. Only one of the other is going to run, and so there's very little chance of the user actually getting into one of these blocks. Therefore, we're just simply going to have wasted code. We're going to have wasted text in our program. The size is going to be larger, and it's not really going to be worth it. All right, so what we're going to do is we're going to use other methods if there's something already available to us. Try catch is great, but it's not necessarily always the best thing. So in this particular example, we use the int.tryParse, and what we can do is we can try to parse a number as an integer and see if it works, and if it does, great. If not, then we ask for another number. If we were try to do something like that as a try-catch block, you'd end up with all of this. So as if int.tryParse or not int.tryParse, we have 2 lines of code. As a try-catch block, we have all of this that we need to keep track of. We also have what's called a finally block. Now finally just simply means that whether the try block ran or the catch block ran, no matter which one of those two ran, finally is going to run. So no matter what, finally actually does something. Now the reason that we use the finally block is typically going to be that we need to do some sort of cleanup. So if we try to do something and it works, great. We need to maybe close a connection to a database. Maybe we need to close a file that's open or something like that. But if we get an error, we still need to close that connection or close that file. All right, so the way that this looks is we end up with a try block, try to do something. If there's an error, catch it, do something about it. And then no matter what, finally do all of these, whether or not there was an exception. All right, so here's another example of it. Here we try to open a file. We try to read the file, place data in it, calculate an average, display the average. And then you'll notice here that we have an I/O exception. So let's say I try to open the file and the file actually can't be opened. Let's say the system can't find it, or in this case the file is already open. Then this will catch the error message and it will run finally no matter what. And the file is open, so it's going to try to close it. All right, so what we can do is we don't necessarily have to catch errors in every little section of code that we have. We can actually catch the error in the section of code or the method that calls the other child methods. So what we're going to do is we're going to create our try-catch block in our main method, and then we're going to create the same blocks in any of our sub-methods. But what we want to do is we want to let the main method handle the error message. What that means is that we actually have to throw, and that's a keyword, throw the error message back to whatever method called that section of code. All right, so in this case we have a price list, and the price list has 4 items, and we're going to we're going to write out to the screen the item price as a string, as currency. All right, so what I want to do is I want to display the item. So this section of code, we have an item. We're going to try to enter an item number. We're going to convert whatever was typed into item, and then we're going to display the price of that particular item. Now, if we end up out of bounds, then it should catch some sort of exception here. And you'll notice here we have console.writeLine e.message plus the price is 0. All right, so what happens is in our code we only have 4 items here. So we have index 0, 1, 2, and 3. We don't have an index 4, but if we try to call item 4, it will catch the error message, and then it will say that we're out of the bounds of the array. All right, so if we try to catch the price, then what we're going to do is we're going to get an error message that says you must enter a number less than 4, and then please re-enter the item number. All right, so I want to allow the user to try to fix their problem. All right, so what we're going to do is we're going to use a while block, and we're going to use a register. So here we have an item, it's a Boolean, and it's called isGoodItem, and it's set to false initially. We have to have it set to false or this thing would never run. All right, so while this thing is not true, then I want to run this section of code. All right, so what we're going to do is while it's not true, try to ask them for a number, and then take the number they enter, convert it to an integer, put it into item, and then run the section of code to display the item. Now the thing is what it's going to do is if I type in 4 here, then it will look at item 4 and it calls it down here, but then what will happen is it actually gets an index out of range exception. Well, if it gets an error message, if we did an exception here, this line of code will never run. So what that means to me is that if I run through this thing, isGoodItem will never become true unless this whole section ran successfully. All right, so if we got an error, we go down here to the exception, then we go right back where we left, and then we try it again. And keep doing this until they enter a legitimate number. If they enter a legitimate number, then we're going to say that the item is good, that's true, so therefore we won't ask again and we'll carry on our way. All right, so in this case, it says enter an item number 12. You must enter an item number less than 4. Please re-enter item number. So then they enter item number 4. Please re-enter item number because it had to be less than 4. Now we enter an item number 3, and now we actually get a legitimate value back. All right, so we have this thing called the call stack, and the call stack just simply is a section of memory that stores the list of all the locations where the system must return. And what that means is every time a method calls another method, then the system has to keep track of where at in memory that method exists. And so if one method calls another and the second one throws an error, then we want to throw that error back to the calling method. Well, the question is, how do we know who the calling method is? Well, it's in the stack. So we can use the stack trace property to be able to figure out what the location is of whatever caused the exception. We can create our own exceptions also. So what we're going to do is we're going to extend this application exception by simply stating that I make a new class. And remember, I can make child classes by simply giving it a name, colon, and then what is it a child class of? Now, it could be a child class of exception or application exception or any of those exceptions that existed at one of the first slides. But what I have to do is specify what kind of exception it is. All right, so if we get a negative balance exception, which is a child of the exception class, then we're going to say the bank balance is negative, and then we're going to display something. Now notice this right here. Our base is exception, and base has a message that would be displayed. So what this means is that I want to override the message that would actually be displayed by sending back this. I'm going to say bank balance is negative. That goes into message. We're going to send that into here, and we're going to send this error back to the actual message that it displays an exception. We're overriding one of the methods in the base exception class. All right, so in this case here, we are going to have a class object where we can get a balance and we can set a balance. And if a balance is less than 0, then we're going to run this negative balance. We're going to call it NBE, and then we're going to throw NBE. Now what this means is that whatever this error is going to be thrown back to the method that actually called it. All right, so here we have a bank account. That's our class object. We're going to call it account, set it equal to a new bank account using the default constructor. We're going to try to set the account number to 1234. Now this is okay because in our class we say that if it's less than 0, then we throw an error, but if it's not less than 0, then we set the balance to equal to whatever the value is. All right, so we're going to set the account balance to negative 1,000, and the user's not allowed to have a negative balance, so therefore we're going to throw an exception for a negative balance exception, and we're going to use the keyword throw and then NBE. And what this does is it returns the error back to whatever method called it. So this little section of code here is going to get an error message. It's going to try to evaluate it, and then that error is going to be thrown right back to this. All right, so what we would end up with is something like bank balance is negative, and then it tells you where it existed. Now notice it says at try bank account dot main. It was in the main method that it did this. We can also rethrow the exception, which means that whatever the calling method is, we want it to handle the exception. So not just simply throw the exception, but rethrow it. All right, so what happens is if the calling method gets an exception, it'll throw the exception over to another method. That method could handle it, or it could throw it back and let the main method actually handle it. So what happens is we are going to use this keyword throw to actually be allowed to take whatever the error message was and just throw it right back to the method that called it. Now to do this, we just simply use the keyword throw. So we're going to catch the exception. We're going to state something like where the error existed, and then we're going to throw, which means it's going to take this exception and send it right back to whatever called it. So if the main method caused an error, then the main method is going to call this. It will get an exception. It'll display something to the screen, throw the error message right back to main, and let the catch block in main handle it. All right, so you can end up with something like this, where you try it in the main method, try it in the method A, tried method B, in method C, caught in method B, and so forth. Okay, what does this mean? What this means is that the program is trying to perform this line. So it's just trying in main method. It's going to perform method A. So it goes over and runs method A. Method A is going to turn around and say trying in method A, and then it's going to try to run method B. Okay, so method B runs. So we go to method B. We write in here try in method B. We try to run method C. We jump down here to method C, and it says in method C. And then now what we're doing is we're going to throw a new exception, and this exception error just simply means that I'm creating a new object which is of a data type exception. It is a new exception, and I just simply want to throw it. This would be kind of like throwing an argument back and forth. Well, in this case, my argument is an exception, and the actual exception is this came from method C. All right, so I want to build a new Windows Forms application, and I want to be able to show you how a try-catch works, but before we can actually show the try-catch block, I need to build an application. So we're going to build one that deals with some arrays, so I'm going to call it arrays and try-catch. And I'm just going to let it build it in the projects folder, so go ahead and click OK. And so first thing, we need to rename it. So give it a title. We're going to go ahead and rename the form to FRM main. Yes, we want to rename everything else related to it. All right, so now we have our form. So we have our basic layout. I want to have a label, a text box, and a button. All right, so the label is going to simply state how many elements do you want to create. So what we're going to do is we're going to let the user choose how big the array is. All right, then we want to have a text box to allow them to type in how many elements they want. And then we need a button to actually perform the creation of our array. All right, so our label here, how many elements do you want? All right, we're not programmatically going to change this one, so I'm going to leave it alone. I don't have to rename it. Now my text box, though, that one I do need to rename. So that's going to be tbx num elements. And then my button here is going to be, cmd create array. Okay, and then the text that's on it is just simply going to say create array. All right, and then I want another label here that what we're going to do is we're going to create the array, and then once we have the array created, then we're going to provide output to display what's in the array. All right, so I'm going to give this one a name, so it's going to be LBL. And this is the output, so I'm going to call it LBL output. Now remember, if we have a label here and we don't have any value for it, so what I've done is under text, I've deleted all of the text that's in it, which means that if I click off of this thing, it will actually disappear. And to get it back, if I click around, I will not be able to find it. But if I come over here under properties, I can still find that label right here. So LBL output is right there. It still allows me to select it. So don't be afraid to delete the text here, because if you do, you can always get it back by selecting it here. All right, so what I want to do is I want to make it when the user clicks on this button, hopefully they filled something in for the number of elements, and then we're going to create an array that has that many elements in it. Now in C#, you have to specify how many elements you actually can have, or how many elements the array contains, and we have to declare the size, and then if we ever want to change the size, if we want to add more elements to it, we have to reinitialize it. So C# is very strict on that. Alright, so what we're going to do is we're going to ask the user how many elements they want to create in this array. Alright, so to do that, we're going to add it to this create array button. We double click. That creates the private void cmd create array click event method. And then what we're going to do is we're going to do a couple things. So I'm going to do this as text first, just write out my pseudocode as comments. So the first thing that I want to do is I'm going to declare variables. Okay, so I need some variables in here to hold things like the number of elements. And then I need to read the data from that text box. Get the number from the text box. Okay, now the problem is when I get the number in from the text box, it's going to be a text string, and I want to convert that to a number. Okay, and then the next thing I want to do is I want to declare my array. All right, and once we have the array, then we need to populate it. So we're going to put some stuff into the array. And then the last thing we want to do is we want to display the contents of the array. Alright, so this is my basic layout. So as far as variables are concerned, I have a variable for the number of elements as a number, but I also am going to need one as a text string, because whatever we get from the text box is going to be a string, and we need to put that into a string value. So I'm going to say int, and because that's my data type, And so I'm making an integer data type, and remember a prefix for an int variable is just simply, once again, going to be int. And in this case, it's going to be int num elements. Okay, so now I've declared that I have a variable called int num elements, and it is of data type int. I did not set it equal to anything, so right now it's just equal to null. Alright, and then I also need a string value to hold the string value from the text box. I'm going to call that str num elements. Alright, so what we're going to do is we're going to get the number from the text box. So what I'm going to do is str num elements is going to be equal to whatever is in the text box. Well, the text box is going to be something like tbx, and I mistyped it. It says tbs, so I need to go fix that. Okay, so now if I come back over here and I type in tbx, it's going to make me type the whole thing again, tbx. Okay, so it won't let me do it. But I called it tbx num elements. So I'm going to call it tbx num elements. And I can't specify that I want to set this string value equal to a text box. I have to set it equal to the text value for that text box. Alright, so then what we're going to have is, once we have that value, oops, I forgot a semicolon up here. Once we have this value, str num elements, we need to convert that to a number and stick it into int num elements. Alright, so I'm going to do int num elements, and we're going to set that equal to, well, I need to convert the value of str num elements to an integer value, so I'm going to use the convert method, so to int 32, and then I'm going to convert str num elements. Okay, so look at whatever str num elements has in it, convert it to an integer, and then stick that in int num elements. Alright, so then the next thing we're going to do is we're going to declare the array. So I need to know how to declare an array. Alright, in C#, to declare the array, we're going to specify that we're making an integer data type array. So the way that we do this is we say int with the square brackets afterwards, therefore it is an integer array. We're going to give it a name, so I'm going to call it int array, because it's our array that holds a bunch of integers. And we're going to set it equal to a new int array. So once again over here we're going to put a set of square brackets. Okay, so what goes inside of the brackets is going to be how many elements should there be in the array. So like if our array had 5 elements in it, we'd type the number 5. Well, we're leaving this up to the user, so we actually are going to make it int num elements. So however many elements they specify is what we're going to put into this array. Alright, so what we do is we're going to ask them to type in the number as text into tbx num elements. We put that into str num elements. We convert str num elements to an integer and stick that into int num elements. And then we create a new integer array called int array, which is equal to a new int array that has this size, or this many elements. Alright, so then the next thing we need to do is we're going to have to populate the array. Now to do this, we're going to use a loop. Alright, so I'm going to use a for loop. And we use a for loop if we know exactly how many times something is going to be run, or we use a while loop if we don't necessarily know how many times it may be run. So something like this where I want to populate the array, I know the array has a beginning element and has an end element. And so what I'm going to do is I'm going to specify this as a for loop, and then a for loop inside of the parentheses we have three sections that we need to put in here. First thing is I need to declare a counter. So I'm going to say int, the int data type. I'm going to call my counter k and set it equal to 0. That's my first thing. Then while k is less than the number of elements that are in the array. So what I could do is I could say int num elements right here. Okay, so while it's less than the number of elements, then what I want to do is set, I want to increment k, so I'm going to say k is equal to k plus 1, and that's what my statement will look like. Alright, but what I can do is I can actually make this a shorthand notation here. Now there are two ways that I can do this. I can change this And instead of saying k equals k plus 1, I could say k, and then get rid of this k plus 1 over here and say k plus equals 1. And what this means is k equals k plus 1. That's one way I can do it. The other way that I can do it is I can use an even shorter notation, which is plus plus k. This is called a prefix increment, and what it does is it will take k, and every time the loop runs, it will add 1 to whatever's in k. So the first time we run through, k is 0. After we're done with the loop, it increments k by 1. Now k would be 1. Next time we go through, it increments by 1, so it would be 2, and so forth. It just keeps running. All right, so then what we're going to do is when the loop runs, I need to put some stuff into the array. So what we're going to do is we're going to say in array, and we're going to look at its k value because that's our counter here. And we want to put something into this. So just for sake of having something in it, I'm going to provide a value here, which is going to be something like k plus 1 and then times 10. I'm just simply making up a calculation so that it provides some value to go into that array element. All right, now what I can do though is instead of saying int num elements here, because that value may change later, I actually can look at my array. My array here is called int array, and it has a length. So instead of saying int num elements, what I want to do is I want to do int array dot, and then what am I looking at? Well, I'm looking at the length of it. So what this does for me is this will actually make it where while k is less than the length of the array, which should match int num elements, but while k is less than the length of the array, then we're going to perform all of this. All right, so then the last line here is going to be to display the contents of the array. So what I want to do is I want to take each of the values that are in the array and I want to populate those out to our label. All right, so I'm going to use a for loop again, and I have to do the exact same for loop. So I'm going to initialize a counter called k, set it equal to 0, while k is less than int array dot length. Then we're going to add 1 to k. All right, so now exact same loop. So what I want to do is I'm going to take the label output. Okay, so LBL output here has a text value or text property that I can play with. So we have an LBL output.text property, and I want to set this equal to something. So what I'm going to do is I'm going to specify that LBL output.text is going to be equal to something. Well, the question is, what is it equal to? All right, it's going to be equal to whatever is currently in LBL output, because what I want to do is I want it to keep adding to whatever is in the output. And then plus, and then some other value. So what am I going to put into this? Well, I'm going to put in int array and then k. All right, so this is just strictly for the purpose of creating an array and then displaying it out to the screen. So I'm going to go ahead and start this. Hopefully we get something that looks like a legitimate program. All right, so now you'll notice we have 10, 20, 30, and they're all crammed together. All right, I want to fix this. I want to make this look a little bit nicer. So I'm going to show you a way to fix it and make it look nice. The way that I'm going to make it look nice is, remember up here where I did, let's see, up here when I did the k equals k plus 1, and then I changed that to k plus equals 1. I can do that with my labels too. So down here, if I have something like LBL output.text is equal to LBL output.text plus something, I can actually change this to plus equals, and then I can get rid of this junk here. Okay, so I just want to show you this looks exactly the same. So if I do 3 things, there's my array, 10, 20, 30. All right, but what I want to do is I want to make this look nicer over here. And the way that I'm going to make this look nicer is I'm going to use a command called string.format. And what string.format will do is it will allow me to format some text in a specific way that I want it to show up on the screen. All right, so what I'm going to do is inside of a set of parentheses, Actually, I'm going to leave out the second one. What I want to do is I'm going to use what's called a placeholder. And a placeholder looks like this. It's a curly bracket, 0, curly bracket, and then a space, a comma, and a space. And inside of the quotes, this is what I want it to actually display. Now, the question is, what does this 0 represent? Well, the 0 is going to represent the value that follows after this comma. All right, so what will happen is it will have 10 and display 10, comma, space. And then it'll get 20 and then say 20, comma, space. And then 30 and 30, comma, space. And what we're doing is we're just simply making the string that formats on the screen look a little nicer. All right, so I'm going to go ahead and run this. And I went 3 things, and now they're spaced out. And you'll see I have 10 and then comma, space, 20, comma, space, 30, comma, space. And the question where those come from is right here. So this placeholder 0 tells it, hey, look at the first thing that's over here and display it there, comma, and then a space. Then the next time we go through, now to look at this again and look at the second array element. Go through again, look at the third array element, and then we're done. All right, so what I want to show to you, though, is this is working the way that I want it to. So if I have 5 elements, then we're going to add 5 here. All right, so I'm going to add 5 more, and you'll notice what happens is it just simply keeps adding them at the end. Well, what I want to do is every time I click this create array, I want it to clear out whatever's in here first and then perform the rest of these calculations. So what I'm going to do is at the very beginning of my CMD create array underscore click, I'm going to clear the contents of LBL output. Okay, and the way that I do that, I'm going to say LBL output dot text is equal to, and then 2 sets of double quotes. What that does is it'll blank out the text, and so now if I do 3, do 5, 6, just do 1, it clears it out each time, and then it only displays the output from our array. All right, so clear the text, get the value from the text box, convert it to an integer, make an array that's that number of elements in size. In each element that's in the array, we're going to add 1 to the value. And the reason I'm adding 1 is because it starts off at 0. So if I just left this as k times 10, then I'd have 0, 10, 20. And I want this to be 10, 20, 30, so that's why I did it this way. And then we display the content. We just do lboutput.text plus equals, which means add this to whatever's already in the text value. And then we're formatting it so that we have a comma and a space before it actually displays the text. All right, so all of that is just building up to a problem that I have. All right, I'm going to run this, and if I say how many elements do you want, and I type in the word 1, and I click create array, we have a section of code that is responsible for converting the word 1 to an integer. The problem is this won't work, because when I click create array, I actually will get an unhandled exception error message. And it says that the input string was not in a correct format. So what we're telling the user is that, hey, you put it in an incorrect format, but what you'll notice here is that the only option is either break or continue. When I continue, the program just exits. All right, so the problem is we have this ungraceful way of handling this problem. The program crashes and then it's done. I don't necessarily want that to happen. I want the program to nicely exit. All right, the way that I'm going to fix this is I'm going to take all of this section of code right here, and I'm going to put it inside of a section of code called a try block. So what I'm going to do is I'm going to tell the system, hey, try to do all of this. Okay, so now what happens is we're telling the system try to do all of this stuff in here and see if it works. If it doesn't work, then we're going to catch this. Now, a catch just simply means that we're going to do something with whatever happens. So this is catching our error message. All right, so this is my default, is just to catch it. So what I could do is I could say something like, you got a problem. All right, so I'm going to use what's called a message box. This is a pop-up box. And we can say message box.show, you have an error. Okay, not very descriptive. All right, but what this does is if there's a problem, it tries to catch it and then it gives this message. All right, so I want to show you something real quick. Notice up here it says debug. I'm going to go ahead and start this, and I'm going to type in 1. And when I click create array, it says you have an error. Now, if I didn't actually get this nice little box here that says you have an error, what you might want to do sometimes, or you might have to do, is change this to release. So if yours doesn't work the way you expect it to with these try-catch blocks, change this to release before you start it. Alright, so what I'm going to do is my message box actually has the option here, and I'm going to put a comma, and then after it I'm going to say error. And what this does is this will be the title bar, this will be the body of the message. So if I do start again, and I type 1, and I click create array, it says error up here. That came from the second part, and then you have an error, that's the beginning part. Alright, but what is the error? I really don't know what my error was. Alright, so what we're going to do is we're going to, instead of saying you have an error, I'm going to do something like this. After the catch, I'm going to say exception. Okay, I want to catch any exception that comes in, and I'm going to put it into a variable location. And typically we'll do EX. The book reference is E, but if you do E, there's already an event args up here called E, and it'll tell you that, that it's already in use. Alright, so we're just simply going to do EX for our exception. And now what I can do is something like this, where I could say, instead of saying you have an error, I can look at the value of X, which is my exception, but the problem is you'll see I get that nice little underscore. And the reason for it is EX is actually an object that got created, and I don't want to show the entire object, I just want to show what's called the message. So I'm going to do dot message afterwards, and then now what this will do is it'll only show the message portion of it, which is text, and it will hopefully display something a little bit more helpful. So if I type in 1 and I click create array, input string was not in a correct format. Oh, hey, that's not right. Alright, so there are ways that I can handle this that are a little bit nicer. Like I could actually put in that if you get this kind of error message that I want it to display something else. For now, I just want you to be concerned with the fact that we can look at the message that's attached to our exception and then just simply provide a little pop-up message. But what you'll notice is when I click OK now, it didn't crash the program. The program itself is still running. So now if I go in and I type 3, it still does 3. If I do 10, I get 10. And if I do Bob, oops, message again. Alright, so if I do -3, arithmetic operation resulted in an overflow. Alright, so now this is a little bit different. Now we have an actual arithmetic error message. But the reason for it still showing me the text here is because I told it, hey, catch any type of exception. Now if I wanted to, I could also specify another catch down here. And so I could do something like catch, and I could say something like arithmetic exception, and we'll call this EX. And I can do that because they're separate. Alright, so in this case I'm going to do message box dot show, and then do something like you need to include or type a number larger than 1. Actually, larger than 0 would work. And that's going to be our error. Okay, now in this case, we actually don't need to catch the exception, but what we're doing is we're telling it that we want to catch this type of error message. Alright, so now, pardon me. So what we're doing is we're just simply trying to catch this error message, and it says the previous catch clause already catches all exceptions. Now here's the problem. This one up here, because it says exception, this would do any exception. We want to put this one first, because now what it'll do is it'll go through this in order. And let's see, EX is declared but never used, which just simply means, let's see, you need to type a larger number than 0, and then, actually this should still allow me to run it. So let's see if it'll run. If it won't, then we'll go back and fix this. But what we're doing is it'll try to go through all of these in order and see if it finds one that matches, and then exception is just like your general, hey, you got an error. And so if I can figure out what type of exception the user entered, then I want to catch that. So if they type in something like they typed in a word instead of a number, then we need to account for that. If they typed in a negative number instead of a positive number, we need to account for that. And then if it's anything else, we just let it go to exception. All right, so here what I'm going to do is I'm going to type in, let's say 1, create array, input string was not in the correct format. Now that went down here to exception because it actually showed me the message. But if I type in -3, you need to type a number larger than 0. So what I'm doing is I'm catching the error message, and depending on the type of error that they cause will dictate what kind of message they receive. We don't want any more than 2 or 3 of these, so we should always have a catch exception at the end here just to catch any generic exception. But if there is a specific type of exception that is likely to occur, then we need to catch those also. So in this case, it's likely for somebody to type text, therefore we need to tell them, oh hey, type a number. It's likely for them to type a negative number, so we need to tell them it has to be a positive number, and then we just simply catch anything else with the exception down here. Alright, I want to play with one more thing. After it performs all of this and it does the output of the array into that label, I want to display the square root of the third element in the array. Okay, so this is just arbitrary. We wouldn't normally do something like this, but just for sake of showing you how we can use the math function, what I want to do is instead of doing k plus 1 times 10, I'm going to do k plus 1 times 100. So now it'll be 100, 200, 300, and so forth in the array. Okay, so the third element is 300, so let's actually do the fourth element. The fourth element would be 400, and we're going to do the square root of 400. Alright, so what we should do is get something out that shows us what the square root is. Alright, so we're just simply going to make a message box. So messagebox.show, and what do I want to show? Okay, so I'm going to have to use my substitution. So I'm going to do like 0 here again, and let's do this. The square root of, and then I'm going to use 0 as my placeholder, is, and then 1, which is my placeholder. Now this is a lot easier than concatenating strings. Alright, so what I'm going to do is 0 represents int array and then my fourth element. Now my fourth element, what you need to think about with the array is my first index is 0. So I have the first one is 0, the second is 1, the third is 2, and the fourth is 3. So it's always going to be one number less. So I want to look at array element 3. That's my fourth element in the array. Comma, and then what does 1 represent? Well, 1 represents the square root of this value. Alright, so what I want to play with is a function called math dot and then sqrt. This is allows me to get the square root of a number. Alright, so I want to look at math dot square root, and I'm going to look at int array 3. Okay, so what I'm doing here is I'm passing in that we are looking at whatever's in int array 3, and I think I have an extra set of parentheses. Alright, so anyhow, what we're going to do is we're going to, let's see, the square root of, okay, the reason for this is I'm actually passing in values with my message box, so it thinks that this is the message, it thinks this is the title, and this is something else. Alright, so I'm going to use another function here. Alright, so my function is going to be string.format. Now what this means is take all the stuff that's in the parentheses here and treat it as if it were a text string. Okay, so now this is a little confusing, so let me show you what it's doing. I'm going to display a message box. I'm going to show it. Inside of the message box, I want to make a text string that's formatted. And the way that we get that text string is by taking all of this stuff that's here. Alright, so we're going to say the square root of 0, which is array 3, which would be 400, is the math.square root of 400, which should be 20. And then we're going to take all of this, convert it to a text string, format it as a string, and then put it in the message box. Alright, so like I said, this is really long, but what I wanted to show you is that we can use this math.square root. So I want to show you how this works. So I'm going to type in that we have 5 elements, create the array, and then we get the square root of 400, which is our 1, 2, 3, 4th element here, which, by the way, is element 0, element 1, element 2, element 3. So element 3 is our 4th element. So the square root of 400 is 20, and we got that by using the math.square-root function. One thing that I want to point out, you'll notice my for loops. I have 4 and then this line, and then I only had one line of actual text for a command. If I want to use more than one line of text for my for statement, what I have to do is enclose all of it in curly brackets. So if I don't include it in curly brackets, this one line is the only line that begins as part or belongs as part of our for loop. If I include it in curly brackets, then this line and any other line that exists between these curly brackets would exist as part of this for loop. So we can use a for loop with just one line or a for loop with multiple lines, but if there are multiples, we have to put them in curly brackets. Alright, so the whole point of this lesson was to learn that we use the try. We're going to try this whole section of code. If anything in this section of code errors out, then it immediately will jump down to the section down here in the catch blocks that correspond to what type of exception we received. And if we have a specific type, then it will go to its catch block. If we don't have a specific one, then exception is just our generic. We received an exception, and it will do this at the end. Alright, so what you need to do is any of the programs that you design, you need to include all of your code inside of a try catch block to make sure that the end user can't crash your program just by entering the wrong type of data.